using trigonometry. So in the first example, I have sine squared theta minus cosine squared theta equal to 0. Now in trigonometry, don't get intimidated with the new symbol theta because theta is just x. So if you're used to seeing x as a variable, you can replace theta by x when you're working on your solution, and then in your final answer, just change it back to theta, just to be consistent with our work. Now for this example, I have an equation wherein I can use the Pythagorean identity in one of the terms. And in this case, I chose sine squared theta to replace it with the Pythagorean identity 1 minus cosine squared theta. Now, can you change cosine squared theta instead of sine squared theta? Of course. So there's no one or single step or single way on how to answer trig equations because some people use a different identity than the other. So it all depends on how you show your work and how you use their identity in solving for x. Now I now have my new equation with the new identity with 1 minus cosine squared theta minus cosine squared theta equal to 0. I can now simplify my equation by combining like terms. I combined cosine squared theta, so now I have 1 minus 2 cosine squared theta equal to 0. And for solving for x or for theta, all I need to do is to have cosine theta by itself. So that is your goal, to have your trig equation or trig function by itself. So I'm getting rid of 1 by subtracting 1 on both sides, and I'll have negative 2 cosine squared theta equals negative 1. I need to get rid of negative 2 by dividing both sides by negative 2, and I'll have 1/2. And since my cosine theta still has an exponent of 2, I can get rid of my exponent by taking the square root of both sides. So now I have cosine theta equal to plus or minus 1 over the square root of 2. Now there are two things that you need to remember when you're simplifying this equation. One is that you need to rationalize your denominator because it has a radical underneath it, and two, you need to take note that you have a plus or minus sign whenever you take the square root of both sides when you're solving equation. So for cosine theta, we have the positive and negative values of square root of 2 all over 2, and we need the unit circle to solve for these function. And in the unit circle, the theta is true for pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So we have 4 values of theta because of the plus or minus symbol that we have used in getting rid of the exponent 2. Now for example number 2, we have cosine squared x plus cosine x minus sine squared x. Now in this example, what I did is I set my equation to 0 for my first step. And when I set it to 0, I decided to change sine squared x to 1 minus cosine squared x because if I do that, I'm going to have all cosine in my equation, and it makes solving the trig equation a lot easier. So now I have cosine squared x plus cosine x minus 1 plus cosine squared x equal to 0. And for solving for x, all I have to do is to combine like terms. Now I have 2 cosine squared x plus cosine x minus 1, which is factorable if we convert it into algebraic expression. So 2 cosine x squared plus cosine x minus 1, you can visualize it as 2x squared plus x minus 1, which you can factor, and it will give you 2x minus 1 and x plus 1, which I then transform into a trig equation based on our problem. And I know that it's factorable, so I can use the zero product property to solve my equation. So I have 2 cosine x minus 1 equal to 0 and cosine x plus 1 equal to 0. And solving for x, I have two values of cosine x. One is for 1/2 and one is for negative 1. And now I'm going to use my unit circle to solve for x to find the specific values of the angles wherein 1/2 or cosine x is equal to 1/2. So I have pi over 3, 5 pi over 3, and pi. Now for my example number 3, I have 3 tangent squared x plus 2 secant squared x plus 1. And using the Pythagorean identity again, because if you've noticed, every time you have an exponent of 2 in your trig function, you always use the Pythagorean identity, and that's what I did. So in this case, I changed my tangent squared x into secant squared x minus 1 using the Pythagorean identity, so that all my equation here will be secant. So by simplifying it, I have 3 secant squared x minus 3 and 2 secant squared x plus 1. And by combining like terms, after setting it to 0, I'll have 3 secant squared x and minus 2 secant squared x that I can combine, and negative 3 minus 1. So I end up with secant squared x minus 4 equal to 0. Now, the goal is to have secant x by itself. So add 4 on both sides and take the square root of both sides to get rid of your exponent 2. And you'll have secant x equals plus or minus 2. Now, secant is not in your unit circle. So what you need to do is to find its inverse, which is cosine. So since secant x is the inverse of cosine x, you take the reciprocal of positive 2 or positive and negative 2, and you'll have plus or minus 1/2. So this is what you will need to use your unit circle to, so you'll find the values of x. So using the unit circle, we'll have 4 values because it's plus or minus, and they are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3.